My name's John Nicholas, and today I want to show you a systematic approach to handling legacy code and discovering business requirements. And we're going to use mutation testing as a way to do that. But we're going to go through a bit of a process. The first thing we're going to do is we're going to take this piece of code, it's legacy code because it has no tests, it's the gilded rose kata, and we are going to increase code coverage to 100%. The reason why we're doing that today, though, is because it makes this example easier to understand because all our mutations will be discovered up front. Normally, when I do this, I wouldn't bother with the code coverage. I'd just go in and mutation test and convert no coverage into mutations. But as you do that, you tend to discover new mutations, and it's a bit confusing. So to simplify, we're doing code coverage first, and then I'm going to make a point about code coverage. Then we're going to do mutation testing to get a set of golden master tests. We're then going to show how mutation testing has some flaws. I'm going to do this by factoring out the value streams and making the code decoupled. And as we do that, we're going to discover new mutations that were masked by multiple things being coupled together. Okay, and that's the course. This is the most important thing here. And then once we've done this, we can then extract business requirements from that, ask some questions about some of the more questionable mutation tests, and then, given feedback from that, we could delete some test cases, delete the code base, and then rewrite the whole thing under the tests we have. So that's the full process. Anyway, I hope you enjoy this. So I wanted to start this with a brief tour of the Gilded Rose Kata. At its heart, we have this function here, which effectively calls a console app program.main, and then it runs that through, capturing the output of the console, and then it compares that output to a stored file, which is where verify.verify comes in. And the stored file is the golden master. We'll generate that shortly. And so this is the golden master test. We're going to use mutation testing eventually to generate many of those. So let's look at what's going on. So program.main is a function that generates a load of items and loops 31 times and updates those items, and it writes to the console while it's doing it. And that's all this program does. When we're doing the code here, we aren't actually going to use this because we want to use a system to discover what the code does ourselves. We don't need to have preset data, but we're going to maintain this loop because that loop actually has a bit of business logic in it. So the purpose of this kata is to discover what this code does in here and refactor it and understand it. And we're going to use mutation testing to do that. So let's continue. But first of all, right, let's deal with a common approach. If you speak to test managers and QAs and QAT people, and a lot of head of engineering and a lot of like heads of whatever, managers in general, what they'll say is, if code coverage is low, you should write more tests to increase code coverage. So let's do that, right? Let's see what happens. So that's going to be our first approach, right? So we change this to food, we run at the test pass. We can now come along and we can run Striker. And Striker is our mutation test framework. And while this is going, we have this gilded test here, and it does a gilded rose in this update function. And the gilded rose is a kata, and it has this horrible piece of code in it. And this piece of code is coupled in many ways. You can see we have AgeBree and Backstage here. So these two things are coupled at once in the same thing. And then down here, it's to do with like either AgeBree on it, and they're coupled again. There's another if statement here, like again, they're coupled in different places, and Sulfurous keeps popping up, right? And then there's code which isn't to do with either of them, so God knows what that's doing. And the reason why this is interesting is this kind of coupling is usually spread across many different classes or functions, right? Whereas here it's all squished into one place. But the thing that I find very interesting about code like this is that the process we're going to go through is we're going to take these concepts, we're going to separate them out, and then we're going to discover more about them as a result. And what we're going to discover is our Gilded Rose thing has about 38% code coverage on it, which is quite low. And when we run Striker, that sort of matters because you see you got these reasons and skipped. Well, it's going to skip a load of mutants for the reason of code coverage. So we're going to increase code coverage just so it stops doing that. And in the process, we're going to show why code coverage, and people who want to increase code coverage perhaps don't really appreciate what it is they're doing. So I'm going to use a mixture of striker and resharper, right? So right now it's saying we're going to ignore mutants. So it's saying we don't have code coverage for this part here. Note our code coverage is 45. Every time we make a change, we want that to decrease. And as we're doing that, that's good. So here, if it's HBRE or it's backstage, it won't go into here. So we're going to create a test for foo, and its quality is going to be greater than 1. And as a result, this piece of code is going to get used. So that will help. So we have a foo test already, which is why I'm thinking about foo. And then we're going to do this. Let's rename this because it doesn't like that. Let's rename this because it doesn't like that. Let's just get rid of like some of these horrible underlying bits. And we run our tests. Boom. That runs. We're going to refresh our coverage. Not going to have to do this every time. Coverage has gone up to 45. We could run striker, which is never a bad idea. It's going to run in the background. It produces output like this, right? So we've got coverage of this. I expect both of these coverage things to disappear now, which means we're in the else. So to get into here, we need an HBRE or a backstage pass, right? And because we have a backstage pass down here, I'm going to do a test for a backstage pass, and that's going to give us a load of coverage, right? Which is brilliant, because like when we increase our code coverage, right, we increase our understanding that our code is doing the right thing. That's the only reason why, from an assurance perspective, we would want to increase our code coverage, right? So we're going to take a piece of code that uses name, selling, and quality, and we have a little test set on, this stuff, right? So now we've gone up to 83% code coverage. This is just finished. We jump over here. Let's have a look at that. It doesn't take into account our last change because I ran it before, right? But there we go. We've got this. And now I've just created this backstage thing. So let's see what happens there. Well, that runs. So we're going to go through. We're going to run this again. It's taking about 30 seconds to run. So we added a backstage, and it has a quality less than 50. Selling's less than that. Quality's less than 50 sellers. So I reckon all this disappears from coverage now. Then we go down and we discover we got some things over here. What is this? Selling of less than 0. So selling goes down for everything apart from sulfurous. So if it's on 0, it's now less than 0, which means we need a foo of a quality greater than 0 by the time we get to this point. So a foo of quality 1 will be 0, so it won't get in. So we need a foo of quality 2, right? And that'll get us into there. Boom. Right, so what's going on now? Our coverage is down to 11, which is ace. Turn that off and that off, so we can see we get all the way down to here. So now, as we're saying, we want a foo quality of 2 to get rid of that. And then this else here is to do with aged brie. So if we have an item of aged brie, that will get through that as well, right? So we've got a backstage. We're going to take a foo. I'm going to do that. Now it's going to be an aged brie. And then boom, run that. Boom, we're at 100% code coverage. So we've covered all our code. It's very rare on code bases that code coverage gets to 100%. Because we have got there, we are at the pinnacle of our stuff, right? So now, once this is finished, we can refactor our code because we know we've covered it. Therefore, we have tests that tell us precisely how the code behaves. So we're now able to refactor, and provided we refactor in the test pass, we know our refactors are safe, right? I mean, if not, then what's the point in writing tests? So we're going to come back and we're going to refactor our code. Now, because our code coverage is at 100%, I can be really reckless, right? And so, for instance, if I came along and I deleted all the code, right, we would quite rightly expect that, like, our tests would fail, right? Because we've just deleted all the code under them, and hang on, they passed. We have 100% code coverage. We deleted all the code and our test passed. Well, unfortunately, that was entirely expected by me because code coverage is not a useful way to validate your code works. And if you have a code base that has low code coverage, the correct solution to like having higher code coverage is not to write tests to increase coverage. It's to turn around and ask why your ways of working involve a team that's not taking examples, writing code for those examples, and then making sure the tests pass those examples, right? I actually don't care if you do TDD. I personally do TDD and highly recommend it. And I know most very effective teams do TDD, but the practice that gets you to high levels of quality is having examples, writing code to make the examples pass, and having tests that prove that your code makes those examples pass. Don't care about the order. I would strongly recommend TDD though. This is an example of increasing code coverage without really having examples. And the reason why the code coverage passes is because it's asserting on foo. And this is what happens when you mock too heavily. If you're doing tests at a functional level or a class level, you'll mock out all your dependencies. And as a result, you actually don't end up testing anything because the behavior of multiple things is actually how those multiple things are coupled together. And you need to test them being coupled together. And when you break it all apart, you end up with nonsense like this. So code coverage is probably the most destructive thing possible. And if you like to increase code coverage on code bases, please take this example as categorical evidence that that's misguided and update your belief system. Thank you. Right. So mutation testing. Why do we like mutation testing? Well, mutation testing does something different. Mutation testing actually tries to change one thing at a time in a code base to see if it can make a test fail, right? And as a result, it is a lot like code coverage in the sense it has the same deficiencies. And what we're going to do here, and let me explain the deficiencies. The deficiency is that if you need to do two mutations at once to express a breakpoint or a change in a piece of code, mutation testing won't find it. And when you have code like this, which confuses concepts like age brew or backstage in multiple places throughout it, it's very reasonable to expect that when you, like, say, change a condition to this, the other one might mask the effect of that, right? And so as we refactor this and extract and pull things out to different ways, I fully expect to discover new mutants. So how does mutation testing work? I kind of briefly explained it. But it'll take conditions like not equals and change it to less than or equals, although that makes no sense with strings. But it'll be like equals, or it'll change it to not equals. Or it will change an and to an or it'll change a string to something else, or it will mess with these to make it less than equal to. Various ways of messing with it. And that's what we're going to look at now. Okay, so we're at a breakpoint. We've done code coverage. Code coverage was useless. It's dangerous. Don't ever try and increase code coverage of a code base unless you go out and get requirements and then write tests for those requirements and make sure the code base passes it. That's a different exercise. That's not about increasing code coverage. That's about encoding requirements into tests, and that is a good thing. We're going to use mutation testing, though, now to explore a code base and try and figure out what it does. We want to take the code, we want to identify what it does, lock that down, then we can refactor the code. So we have a few problems here. We have an approval test, which is here. And this approval test calls program.main, right? And program.main is an isolated thing that takes no arguments. I've already pointed out that program.main also is not coupled to anything like a database. So program.main is actually a pure function, and every time it is run, it will produce the same output, right? Which is nice, but it's very simple, right? And it's also pretty untestable, right? Because look, there's this console.write line up here, and then it creates some stuff, and then it starts doing things. Really, this is part of the behavior. So I can move this console.write line down to here. And now what I want to do is I want to extract this piece of code, because this is the unit that I want to test, right? End-to-end, outside-in style, right? So I'm going to extract this onto a method. And the method's going to be called doStuff, because I like naming, right? And then we're going to notice things like this method runs for 31 days. Well, we want to be able to change that, right? So we're going to extract that to a parameter. And then we notice we've got this console.write line. And over here, we can see that, they're using some clever stuff to redirect how console behaves, right? Which is fine and great for a single approval test, but in our case, we're going to have multiple tests running concurrently, and it's going to clobber each other. So we can't actually rely on this. That's not going to be good. Also, we don't want to run for 30 days. We want to run for 2 days. So we're going to create a test for 2 days. We're not going to depend on this stuff because we don't want to depend on console. And so now we need to figure out how to get main to not depend on console, right? Well, it turns out we can take this function here, and we can refactor and extract a method. Oh, I did that wrong. We can extract a local function, and we're going to call this writer, right? And that's great. And now what we're going to do is we're going to convert that function to an expression body like this. And then we're going to go a step further, right? Because I don't think we can't extract parameter on that, right? So what we're going to do is var writer. Oh, no. I'm going to do one thing first, right? We're going to extract that to be a parameter on the writer, yeah? And it's not oh my god high, although I quite like that as a I like that as a parameter name. There we go. We've got writer message. We still can't extract this, which is fine. So we're going to make var writer equal string message to console thing. There we go. Well, it's just going to be happy, right? So we're going to push that to parameter as writing, and that's going to appear in console.main now, right? That's overcomplicated. We can just pass the function. There you go.
And then we're going to replace all the console.write lines with writer. There we go. Boom, right? If you run all the tests, everything will pass. Oop. We run, why is that fail? That's my 2 days failing. That's fine, 2 days should fail, right? And so now we've extracted this, right? We need to go one step further. Well, we don't need to. I'm going to go one step further, and I'm going to pull that out and put it on a separate class.
And we're going to put it on the class doers because we like doers, because doers do things, right?
Then we can do this. We can extract it into its own file. Boom, right. And the point of that is on our approval test now, instead of doing program.main, we can do doers.do stuff, and we can pass in a new list of item. We can make it run for the 2 days we talked about earlier, and we can do a new function, which is going to take a string s, and it's going to go fake outputs.endLine, which is also a lot like a console, and it's going to take the s, right? So this is going to take a string builder, which is just an efficient way of taking strings. I'm not going to get into that, it's a .NET thing. And it's going to call do stuff, and then at the end of it, as it's instead of doing console.writeLine, it's going to add lines to this fake output, and at the end we're going to grab the string of that and verify.
So if we run this now, I'm hoping I get this opening up. There you go. So with no items in 2 days, this is what our output is, which is expected, right? So now this program lets us do this, which copies the file over. And because we know the code is always good, because the code is always good, bit of a tautology, now the test pass. So we have our first test here.
So now I can comment out the old test, which is important because it has quite good coverage, because it's a cheat. We can go to program, and we can comment out the content of program. Oops, there you go, right? So, UL, everything should pass. Now we only have one test, and now we can start running.
We can see we have 4 mutants, right, with no coverage. Now there's a really interesting thing going on here. We passed in a list of that's empty, and then we call this do stuff function. Okay, so let's have a look, right? So doers has no coverage on here, and it's because items is empty. If we just add items into that whole thing cleans itself up. So let's add a first item in here.
And well, the item we're going to add is a new item, right? And it's going to be the same item that we added in our test, actually. The first one we added is foo, right? And quality 0, comma, selling 0, right? UL.
And there we go, we get this, right? Which is cool. So when quality 0, it stays there. So we've just fixed, hopefully, we've seen this as a thing, right? Which is you can delete the whole thing. Now, I think we'll just address that because we've added a new item, and we've added an item with some kind of quality in it, which means we're going to get to this piece of code here. This piece of code requires a quality greater than 0, and our quality is currently 0. So you can see it's changing one of the strings to nothing, changes the quality instead of a not, changes the other string to nothing. So what it's saying is it doesn't matter what string's in there, this whole thing's a no-op, right? And it's a no-op for a couple of reasons. One is we haven't played with the quality enough. I'm pretty sure I just changed that though. I just haven't. So if we do an item with a quality of 1, right, that's not 0, it should make a difference. There we go, we get that through, which is fine. Paste, dump. So I'll do that. If we add an HB and a backstage pass example, it's going to help with some of this stuff, right? But it's only going to help with those things if the quality of those things is greater than 0. Otherwise, it's like a no-op, right? Because it won't ever get past this thing. Because what it's going to do for HBree is it's going to change it to be not empty string, so HBree falls through. And if the equality of the HBree isn't over 1, it's effectively done nothing, right?
So we create an HBree and a backstage of quality 1. Boom, right?
Enter, check that's good. Okay, so we ran a thing. So there's a thing in here that's now greater than 0 or less than 0, right? So we have a 0 example, but we don't have a 1 example, say, right? So it's yeah, we need an example that's not 0, right? So let's run this donk, right? Okay, so now we've got a few things. Let's paste. So now what have we got? We have a better place, right? We have backstage pass is still complaining. We can delete all the things. We have a breakpoint on 0, which is like says, hey, if we set it to less than 0. So what it's saying is this has no effect if it's less than 0. There's 2 parts to the if statement. And so let's focus on the inner side part, right? Let's make a sulfurous hand of Ragnaros. And what that's going to do is, the quality needs to be 1 so it gets into it, right? So let's do that.
Yeah, so that's not really with this. You see the same, so that's interesting. Let's go through here and paste that. Here we go. Run this.
So we added some sulfurous in there. It's interesting that makes no difference, though. Did we do the quality of 1 on the sulfurous or not? Quality is 1 on sulfurous. Very, very, very. Ah, shit! We forgot to make the test pass. Yeah, this has to be passed. So I'm intrigued. So we should do a foo where the quality is less than 0, and that'll flush this out, right? So now if we have a foo, quality less than 50, what's it saying here? Okay, so it's saying less than equal to get through, right? So let's just make a backstage pass, because this is where it goes into it, with a quality of 50. And let's see what happens, right?
Okay, so we've come along, we've done that. Have our things been making it go up?
So when I was just looking at there, is the mutation score. And if the mutation score gets better, our tests are doing positive things, and they have been, right? Which means our examples can stay. But if they ever go down or stay the same, that means our example has achieved nothing, and therefore we will eliminate it. So here we are again, right? So now it's gone 61.54. Last time it was on 60.26. We have made a minuscule difference. We had an example of less than 50, hoping it would affect this, and it hasn't. Now I actually understand what's going on here, but let's keep going. So quality of 50 comes all the way through here. We tried to change this by setting something to 50. It didn't happen. So that tells me that the reason why this exists and the reason why that exists, given we've done backstage in both cases, is outside of this function, is outside of all of this. And that's probably why getting rid of this is possible. It means that, so something's going on outside of these that makes this stuff irrelevant, right? And we get down here, we've got this sulfurous hand of Ragnaros, which has no mutations over it. Then we have this, cell in less than 0. And we can make it less than equal to 0 at the moment. Which means we have nothing that has. So if we did something that has a cell in of 1 that was not a sulfurous, it would change that condition there and make sure it works right. So let's do a backstage with a cell in of 1.
Now we're on 83. It's definitely higher than it was before. So the last change was a good one, right? So what's going on?
Let's focus a bit lower down, because I'm pretty confident this stuff here, this mutation here, so if there's a foo, you can delete this. Why is that, right? Well, if it's a foo and quality is greater than 0, it takes 1 off. And then down here, it's not HBree, it's not that. Quality is greater than 0, it takes more off, right? So maybe we need to have a foo with a quality of 2, and that's probably going to get us into this bit, right? Okay, so let's try that. That might help that other mutation at the top as well. So let's do a foo of quality of 2. We're at 91.03, so we're making progress. But we still have this guy here, right? Complaining about less than or equal to 50. And that is an age brie or a backstage pass. So maybe, and we have some backstage pass stuff going on, and there's a timeout on that. Less than and equal, I'd expect that not to work. So why is that? Value of 50. Why is this? All this code here makes no difference. Well, let's go down. Its sell-in was 0. It took 1 off it, so it's -1, so it goes into here. And it's a backstage pass. And so this runs, right? Which takes the quality to 0. So we need a backstage pass to quality 50 with sell-in of 1 for it to be effective, right? 92.31 before we were on 91. We're now on 92, so I'm glad we're splitting hairs. So now we've got this sell-in thing, and we've got this handle sulfurous in here, and I want to get this one. So why does that not matter? Well, because we don't have a handle sulfurous with sell-in that's negative. So we can pop that in there, right? Sulfurous with negative sell-in. Let's sell it equal to. What's that correspond to? That's an age brie. So if you have an age brie of 50, that would be fine. Sell-in has to be 0 at the beginning, though.
Let's do that. Oh, we don't have one of those, right? So nice, we'll try some easy things that we can just like do. Boom, sell-in of quality 50. Right, let's go back to this. What else have we got?
Let's try, right? Yeah, that'd be good. Right. Whoa, there's some timing ones. Let's get rid of them. So yeah, we're down to these two now. So I reckon we want 49 and 11, right? Key value to look at the moment is 94.87. Right, I'm off. Which sort of breaks my rule. I'm playing an optimization problem here. I don't think I'm going to get away with it because whenever I'm clever, I don't get away with things. So let's see what happens. Okay, finished. Right, let's go. So we're on 96.15. We were on 96.15. We have achieved nothing. So this change was not a good change. Let's delete that shambolic wreck of a test. 48 seems to be a good number. Why don't we have 11 and 48? Okay. 96.15, 94.87. So 96.15 is a good thing. 49 and less than 11. 97.44 is an improvement over 6.15. Have a look. Okay, so we got through this. So now we're saying less than or equal to 6, so we want a breakpoint of 6. A value of 6 makes no difference. So do we have a value of 6? No, we don't. So let's start with that, right? We want a sell-in of 6. And for this to matter, it needs to be 49, 48, 47, right? So 6 and 47. Yeah, 98.72. We know we have this. So here we go again, but we've still got the same values before. So that last thing we put in was crap. So let's get rid of it. So for the 50 test, the value of 48 will come out of 49. I'll put it as 50. So we want 48 and a higher value would work, right? So 48 and 5. There we go, we're at 100. So now we have a set of examples that have no surviving mutants. So this is effectively a set of golden master inputs that we can now use to refactor the whole code base. So that's the next stage of the problem, right? We can prove this sort of works because if we come along and we go into gilded rows and we pick anything, right, and change it to less than or equal to, and run the test, something should fail, right? Boop. Right? There you go, it fails now. So we can revert it, run it again, and everything should pass. There you go, right? So we can do this on everything. So now what we can do is we can refactor the code base behind those tests and see what happens. So yeah, so we just mutation test the whole code base, and now we have no mutants. So now what we can do is we can do two things at once. We can start writing some tests for things, and we can start refactoring things. But to begin with, we're just going to refactor, and we're going to start using code coverage to help us. Boom, 100% code coverage. So now the way we're going to refactor this is my favorite way of refactoring. We're going to add an if statement, and then in that we're going to do something fun. In fact, before we do that, let's going to switch this to for each. There we go, and then it's going to be item T. There we go, right? So my favorite way of changing code is introduce an if statement. So in this case, it's going to be item.name. Wow, that was really cool. Item.name equals age breed. Just because it's the first thing I can see, right? And we're going to do a thing. Else, we're going to do a thing, right? And the question is, where should the else sit? And the answer is around all this code. Boom, right? Well, that should pass. That's not at all scary. Oh, well, it's going to fail, right? Expect the test to fail because we've not done nothing yet, right? Let me, so let's take all this code in here, right, and copy paste it into the if statement. And then we expect it to pass, right? There we go, everything should pass. There we go. So now we can refactor. We have an extra if statement, so now we can start like peeling bits out. But this is where it gets fun, right? And this is what I wanted to show you, is because we have full coverage, we can do this. I don't need to think. I can go, oh, well, that's not covered, right? Therefore, I can delete this. I can delete that. UL. That's ace, right? Now I can come along, I can run code coverage again. Oh, this isn't covered, right? So it's the point is this isn't important. Now I might stop and explain quickly. So that's great. I can just delete this, but I'm going to explain it to you. Item.name is age breed, so we know an item.name cannot be that, therefore we can delete it, right? So logically it's quite simple, but equally, we know we can delete it because code coverage says that. There you go, code coverage is the same. Turns out item name not breed, which we know it is. So that's why that's highlighted, right? Control UL, does it pass? Yes, it does. Cool. Let's go through. Let's keep going with this, right? We're going to run code coverage again. And we're going to find more code. It's not 100% code coverage. Therefore, there is code we can delete. And this is maybe a point I hadn't made before. The way we're using code coverage is we're deciding what code to delete because the code that's not covered is code we don't need anymore, right? We are not writing code to increase code coverage. We are using code coverage to delete code that ain't important. Then we're running the tests. They all pass, right? So now what we can do is, given our nice new simpler code, we can go off and run the mutation tests again, right? And let's see what happens. So I'm going to jump over here. I'm going to start playing Go again. When it finishes, it'll pop up. Well, sunked. 96.59. Last one was... Ooh, so it's found some mutations. Where are these? So, here you go. So what's this one? If name is HBRE, and then it says if name is not that. Right? So it's going to be an empty string. We know it's never that. Therefore, we can just get rid of the check, right? So code coverage doesn't pick this up because the check is still valid. But mutations pick it up and tell us we can delete it, right? What else pops up? If selling is less than 0. Well, this works the same if selling is less than equal to 0. So we found a new mutation here, right? This is cool. So by separating out the concerns by their type, and bear in mind the type of thing is going to change for different reasons, right? So sulfurous will change for different reasons for HBRE. So that single responsibility principle will help in the mutation framework tell us that we've missed something interesting. So maybe we don't have an example of age debris with a cell of 1. We do. Oh, we don't have an age debris with cell of 1. Okay, we found a breakpoint. Well, bloop, that won't pass. Let's do that. Paste. Do that. Let's give it a go. Okay, now we're on 98.82. For 96, so we got a bit better, right? Cool, let's have a look. So now what it's saying, if it sets age breed to 0, it makes no difference, right? Why do you think that is? Well, because age breed never comes through this anymore, right? So this is saying we can factor out the age breed bit. Let's try it. So let's take that out. There we go, we killed all the mutations. So now we can continue our refactoring adventure, right? So else if item name equals this, else everything else, right? So we're going to come down, we're going to select all this. We're going to keep going. There we go, copy all that, stick it in, we expect this to run and pass. Okay, cool. So what do we do now? Well, we run code coverage, right? Run and cover. Okay, so we have code here that's no longer used. It's all this stuff. Tell because it's gray, right? Well, that's not used. Yeah. Still passes. See what else isn't used. Rerun the code coverage. There we go, that's not used. None of this is used. So we're just deleting code simply by looking at the code coverage, right? This fills me with joy. Appreciate might fill people with fear, right? The point is this is pretty brainless. And this is refactoring, right? Refactoring is usually like, you know, scary, right? But it doesn't have to be. That's kind of the point I want to make here. So let's run Striker again, mainly because I want to go and play Go. Oh, what do we do? We want to save it. Here we have some mutants to murder. So in this, apparently this is a thing because it's not checked anymore. Let's go off and check it. There. So that was the only mutant really. It's interesting. No, there is another mutant. Okay, so what we're gonna do is we'll do that. Okay, so time our mutation scores gone up. So we have a weird thing down here for our foo, right? Where foo sell it can be not. So we need a foo with a selling of 1, I think. So what happens? So this is a selling is that the quality is greater than 1, then we lose a quality on it. So we need something with a quality of 2 and a selling. That's 1. Right. Yeah, so we got limitations. If no equals must be also furious, right? And do a thing else. Cool, so let's see what the test do. Test pass. That's the quick also. So furious doesn't do anything. That's cool. So we added Sulfurous Hand of Ragnaros in. Apparently if you change the name to nothing, to not Sulfurous, it has the same effect. That's because we have all these in here, right? So if we take them out, it won't be true anymore. Okay, we're on to 100. So we have fully refactored this. Okay, so what's next? Now we have a full set of examples. after we've separated this. It's very interesting that as we pulled it apart, we found more mutation tests. Those mutation tests would found more edge cases, right? So now I'm really confident we have this covered. So what we can do now is we can start extracting what I would call business requirements from this, right? Now the code is in a place where it's simple enough that we can start saying, well, aged brie, what it's doing is, well, if we move this down, and we say that's less than equal to 0, you can start to see quite clearly that we're saying that HB selling always decreases. The maximum quality is 50, and the quality goes up by 1 every time. But if the selling is less than equal to 1, it goes up by 2. So we can write a series of tests to encodify that. And that's what we'll do next, right? Because I think so. When I got to this point in the refactor, I'd been going at this for about an hour and a half, maybe 2 hours in the evening after a long day's work. I was absolutely shattered, so I never finished it. But what we should do now is we can pull all these tests out into proper examples. We write those as proper tests, as like a given when then, or whatever your acceptance test format is. It could just be blah, 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 will, nested classes. However, build a set of good tests. I'd take them to the BA and I'd be like, right, which ones of these are true and which ones are false? For instance, on this age brie one, you see how the quality is less than 50. Well, that means that if the quality was 51 or 55, it would not get modified in this running. And that's a really interesting example, right? And I don't think that's the intent of this, but it is certainly the behavior of it. And that's the kind of thing you take back up and you double check, right? Because actually it's probably meant to be a cap at 50. And so if someone did create an item of 55, maybe the item should throw an exception earlier on in this code. Maybe it should then reset it down to 50. We don't know. We have to go and ask somebody else. So that's a really good example of a requirement that comes out from asking questions about edge cases. Once you get those requirements clarified, you can build up your set of test cases, and then you can basically rewrite this code to make those test cases pass. Anyway, that's how I'd conclude this. I might go and do that in a bit, but as I don't have a BA, it's a bit pointless. But I really hope you enjoyed this. It was a colossal amount of work to make this video, so thank you very much.